Hi students, now we are going to learn how to find the solutions of a physics past paper. Past paper 3, okay, theory core on February March 2022, past paper number 32. Okay, let's start. For number 1, figure 1.1 shows some meshes on a mesh hanger attached to an elastic band. The elastic band is stretched by the meshes. Okay, this is the hanger. Okay, and this one reaches support. Okay, you may look this. Let's we find the question. Okay, the total mass of the meshes and the mesh hanger is 300 grams. Calculate the total weight of the meshes and the mesh hanger. So we're going to calculate this total meshes. Okay. Uh, as you know that this mass is 300 grams. Okay. And then we're going to calculate with the formula W equal M times G. Okay. It means W equal 300 grams. Oh, I'm gonna convert first. 300 grams equal 0.3. 0.3 newtons. Sorry, 0.3 kg, I mean. 0.3 kilograms. Okay. So 300 grams equals 0.3 kilograms. So here 0.3, okay, 0.3 kilograms times 10 newton, 10 newtons per kilograms. Okay. Why 10 newtons? Because this is the gravitational force of the Earth. Kg over mkg cancel, divided becomes 1. And 0.3 times 10 equal 3. So the answer is 3 newtons. Okay, continue. Students push the mesh hanger down, okay, and then release it. The mesh hanger and meshes oscillate up and down. The students uses a stopwatch to time 20 oscillations. Figure 1.2 shows the time reading on the stopwatch after the 20th oscillation. Okay, this the stopwatch. Okay, determine the time in seconds for 20 oscillations from the time shown in figure 1.2. Okay, so for 20 oscillations, you look this 1 minute. Okay, yeah, 1 minute, it means 1 minute, it means equal 60 seconds. And then this one 6 seconds. Okay, 6 seconds equal 6 seconds. And then this one 0.40. Okay, equal this 1 over 100 seconds, so it means 40 over 100 equal 0.4. Sorry, 0.4 should be here 0.4. Okay, second, and if we add becomes 4, 6, 6. Okay. So 64 time for 20 oscillations is 66.4. Okay, next. Calculate the time in seconds for one oscillation. If 20 oscillations, 66.4, it means for one oscillation, 66.4 over 20. How much? 3.32. So the answer here, 3.32. Okay. Next. When the students pulls the mesh hanger down, energy is stored in the elastic band as elastic potential energy. Describe what happens to his energy store when the student releases the mesh hanger and it moves upwards. Oh, okay. Okay. It means it is about energy. So elastic potential, sorry, elastic potential energy decreases while kinetic energy increases. Okay, let's continue. Oh, number 2. Okay, a student is doing some physical exercise. Figure 2.1 shows the students holding a 50 Newton weight. Okay. The pivot in the shoulder is 0.9 meters from the center of mass of the weight. Calculate the moment of the weight about this pivot. Okay, we're gonna calculate. But you have to look this the distance between this shoulder and the center of mass is 0.9. Okay, while the mass is 50 newtons. Okay, it means moment. You're gonna find the moment of the weight. Moment. Okay, moment of the weight is 0.9 meters. Okay, times, yeah, times 50 newtons. And the result is 45 Newton meters. Okay, it's 45 Newton meters. Okay, Next, B, the students does some running exercise. Figure 2.2 shows the speed time graph for one exercise. Okay, this is the graph. Okay, you may look on your past paper. So you have to download first this past paper while you learn these explanations. So describe the motions of the athlete in sections A, B, and D, E. Which one? Sections A, B, and D, E. Okay, the sections A, B, okay, and D, E. Okay, yeah, that's one. So section A, B, okay, at section A, B, the motion increase, okay, uh, yeah, or it has acceleration. Okay, so look the graph. Okay, and then for section DE, this one DE, the section DE, the motion was stopped. Okay, or at rest. Okay, yeah, because it's 0. Okay, next. Calculate the distance moved by the athlete from time 0 to time 5 seconds. Okay, look up time 0 and time 0 to 5. Okay, 0 to 5. Okay, okay, 0 to 5. This triangle. Okay, okay. This triangle we need to calculate this triangle area. Okay, so it means a half times 5 times 8. Okay, I calculate here. So distance equal, yeah, distance equal area triangle. So it means a half times 5 times 8 equal, yeah, 20 meters. So the answer here, 20 meters. Okay, next. Figure 3.1 shows a metal block and its dimensions. Okay, this calculate the volume of the metal block. So the volume equal 2 centimeters times 2 centimeters times 12 centimeters. So it becomes 48. Yeah, 48 centimeters cube. Okay. The answer here, 48. Okay. Next. A different metal block has a mass of 86 grams and a volume of 8 centimeters cube. Calculate the density. We're gonna calculate the density of the metal using this equation. This is the formula of a density actually. So density or rho equal mass how much? Yeah, the mass is 86 AXC 6 grams over the volume. Okay, volume is 8. Yeah, this volume 8 centimeters cube. Okay, so if we calculate, divided becomes 10.75. Okay, next. The metal block is placed in some liquid. The metal block floats on the liquid. Suggest a value for the density of the liquid. So, uh, the value of the density must greater than, wait, greater than 10.75. Okay. Next. C. A student has a measuring cylinder, a beaker of liquid, and a balance. Describe how the students can use this equipment to determine the density of the liquid. Okay. So measuring the cylinder first. We should measuring mass of cylinder. Okay. And then two uh, pour, okay, pour liquid inside the cylinder and measuring the mass. Okay. Thirdly, okay, find liquid mass through this calculation, through the calculation, calculation or formula. Okay. Uh, yeah, liquid plus mass, liquid cylinder minus cylinder. Okay. Yeah, liquid mass, liquid plus cylinder minus cylinder. Yeah, this is mass. Okay, mass of liquid plus cylinder minus mass cylinder. And four, fourth, find volume, uh, yeah, find volume, and then find the density. Find volume, and yeah, better five here, five, find the density, find the density uh, through a formula, mass over volume. Okay. Next, number four, coal-fired power stations provide electricity for homes and industry. A government decided this. A government decided to replace a coal-fired power stations with a hydroelectric power station. Describe how electrical energy may be obtained from the gravitational potential energy of the water behind a hydroelectric dam. Okay, so we should explain here, I think, regarding uh, yeah, hydroelectric uh, hydroelectric dam. So water is water with gravitational potential energy. Okay, flows through pipe, and then afterward falls down uh, to turbines, and it spins, spins turbine, implicated, and yep, implicated to spins generator. Okay, one. Next, B. Apart from cost, state two advantages of generating electricity using a hydroelectric power station compared with using a coal-fired power station. Okay, so first we gain energy from renewable energy. Okay, and secondly, during operation, there is no harmful, there is no harmful gas, yeah, such as CO2. Okay, CO2. Okay, yeah, CO2. Oh, sorry, CO2. I'm gonna write here CO2. Okay, and next, C. Apart from cost, state two disadvantages of generating electricity using hydroelectric power station compared with using a coal-fired power station. Okay, so the C, it needs large area. Okay, it needs a large area of land flooded. Next, uh, it will damage with life habitat. Yeah, habitats. Okay. Next, number five. Okay. A woman starts to push a trolley across the floor. Figure 5.1 shows the horizontal forces acting on the trolley. Okay. So determine the resultant horizontal force on the trolley. Okay. Uh, so resultant, uh, the resultant, okay, R equal 120 newtons, 120 newtons minus this one 90 newtons. Okay, equal 30 newtons. The answer is 30 newtons. Our direction, the direction is to forward. Okay, forwards. Okay, let's we continue to B. The total weight of trolley and boxes is 900 newtons. So this is actually F. This is F of force. Okay. And the area of each wheel in contact with the ground is 8 Newton centimeter square. The trolley has 4 wheels. Calculate the pressure on the ground due to the total weight of the trolley and boxes. Include the correct unit in your answer. Okay, so this is the area of each wheel, and the formula for this problem is pressure equals force over total area. Okay, so it means pressure equals 900 newtons. Sorry, this one, I mean Newton, 900, I mean, okay. Over 8 times 4, okay. Okay, 8 centimeters squared times 4 because 4 wells. So 900 divided by 32. 900 newtons over 32 centimeters squared. Okay, I will calculate first with calculator. And the result 28.125 newtons over centimeter squared. Okay. So this the solution. Pressure on the ground 28.125, while unit Newton per centimeter square. Okay, next. Figure 6.1 represents gas particles in a container. The container is at room temperature. This container wall and gas particle a lot inside. Describe the motions of the gas particles. Okay, the motions of the gas particles. Okay, moving at high speed, okay, and it moving, it moving, it moves, moving, uh, random direction, directions, and it's college, college within other particle. Okay, next. B, state how the motion of the gas particles changes when the gas in the container is collided. Okay, so B, molecules motion would be slower, yeah, gradually, yeah. C, explain how the gas particles exert a pressure on the walls of the container. Okay, so when the particles uh, collide, okay, collide the container wall, the particles the particle force, yeah, exert a pressure. Okay, that's next. Okay, state the name of the transfer of thermal energy through a metal. Oh, conduction. Okay, next. A metal can contain some water. The metal can is heated as shown in figure 7.1. Okay, this one, the figure 7.1. Okay, describe how thermal energy causes the movement of water shown in figure 7.1. Okay. Uh, yeah. Thermal energy implicate sorry, thermal energy implicate to heat water when water heat molecules expand, become less dense, okay, and rise upwards. Okay, I did that. Now, 7C. A student places equal masses of water into two metal cans. The cans are identical apart from one having a white outer surface and the other having a black outer surface. The student places the two cans in direct sunlight. The temperature of the water increases in both cans. After 10 minutes, the temperature increase is greater in one of the cans. State and explain which can has the greater increase in temperature. Okay, so C, of course, black hand. Okay, why? Because black hand is a better absorber. Okay, yeah, I think that's the solution. Next, number 8. A student uses a tank of water to observe waves on the surface of the water. A. The graph in figure 8.1 represents a wave on the surface of the water. Okay. Next, draw on figure 8.1 to indicate the amplitude of the wave. Label the amplitude A. Okay, so amplitude, this is this from this one. This is amplitude A. Yeah. Okay. Draw on figure 8.1 to indicate one wavelength of the wave. Label the wavelength L. Okay, one wavelength from this one into this one. This one wavelength. Okay, this L. Okay. Next, the student creates waves in the water tank, and places various barriers in their path. Figure 8.2 shows the wavefronts as they approach a barrier placed at an angle of 45 degrees to the wavefronts. Okay. This is the figure 8.2. On the figure 8.2, draw three wavefronts after they have reflected from the barrier. Draw an arrow to show the directions of travel of this wavefronts. Okay, so usually it will be like this. Okay, the direction, and yeah, there this must be 90 degree. Okay. Mm. And the wavefronts this. Okay. Yeah. Like that. And next, on figure 8.2, draw three wavefronts after. Okay, already. That one. Next, the students replaces the barrier on figure 8.2 with a different barrier as shown in figure 8.3. Figure 8.3 shows the wavefronts as they reach the barrier. Okay. A narrow gap here, it means it becomes, yeah, of course, the direction this, and yeah, yeah, to all direction. Okay, and this. Okay. Okay, this one. Draw three wavefronts. Okay, already. Next. 9. Number 9, figure 9.1 shows the regions of the electromagnetic spectrum. One region is not level. Okay. In figure 9.1, one region is unleveled. State the name of the unleveled region. Okay. 9.1. Oh yeah, microwaves. Yeah, I think I hear microwaves. What else? Number two. Complete the sentence. The directions of the arrow in figure 9.1 shows the regions of the electromagnetic spectrum in order of increasing increasing frequency. Okay. State two uses for X-rays. Okay. Uh, for yeah, for scanning bones, and then yeah, oh yeah, for treating cancer. Okay. State why X-rays can be harmful to people. Okay, because yeah, actually X-rays are ion ionizing radiation and be able to damage human body. Okay, human body cells, and then living living tissue and DNA and DNA. I mean, okay. What else? Next. Okay, number 10. A student connects the circuit shown in figure 10.1. The students want to determine the resistance of the light-dependent resistor, LDR, though on figure 10.1 to show how the students connect a voltmeter into the circuit, use the correct symbol for the voltmeter. Okay, so we should draw like this because the voltmeter attached as parallel circuit. Okay, next, the current in LDR is 0.02 amps when the potential difference or voltage across the LDR is 5.4 volt. Calculate the resistance of LDR. Okay, it means, yeah, this is potential difference, and this one at the electricity current. So the resistance equal R equals P over I. So resistance equals 5.4 volts over 0.02 amps. So it's gonna be 270 ohms. Okay. So the answer is 270 ohms. When the student shines a light onto the LDR, its resistance is 150 ohms. The resistance of the variable resistor in the circuit is 180 ohms. Determine the combined resistance of the LDR and the variable resistor. Okay, so it means combined resistance, or R. The combined resistance is 150 ohms plus 180. 180 ohms equal it equals 330 ohms. 330 ohms. Okay. A battery charger for a laptop computer includes a transformer. The primary voltage Vp to the transformer is 240 volts. The number of turns on the primary coil Np is 590 turns, and the number of turns on the secondary coil Ns of the transformer is 48 turns. Calculate the secondary voltage of the transformer. Okay, so the formula to find this solution, the formula uh, is Vs over Vp equals Ns over Np. If Vs is the subject, it means Vs equals Ns over Np times Vp. Okay, so it means Vs of Vs equals Ns how much? Ns this one, okay, 48 over Np, which one? Np this one, okay, 590 times Vp, this one, 240. And if we calculate, it's gonna be 19.53. Okay, so the answer here, 19.53 volts. The plug connection, the transformer to the supply voltage contains a fuse. Describe how a fuse works. Okay. The fuse breaks the circuit. The fuse breaks the circuit if a large electricity, current flows and will damage electrical tools. So the fuse protects the wiring and the appliance if something goes wrong. Okay, that's the answer. Okay, next, number 12. Table 12.1 gives some properties of three different types of radiation. Okay. Complete table 12.1 by writing the missing property in each of the empty boxes. Stage, oh, this one first. Okay, it means this one is electron. Okay, and this is 0 minus 1 minus 2. This minus 2. And yeah, of course, it is high. Okay, no, and so number 2, state which type of radiation, alpha, beta, or gamma, is the most penetrating. Of course, gamma. Okay, gamma. An isotope of a beryllium Be has the nucleate notation. Nucleate notation, this one, figure 12.1 shows a diagram of one atom of this isotope. Okay. Complete the labeling of figure 12.1. State the names for X and for Y, of course. X is a proton and Y is a neutron. Neutron. Okay, done. Okay, thank you, students, for joining with me in this lesson. See you.